Hands up who knows what a transcoder is? No transcoders? One transcoder? Asymmetric polymorphic signal transformation? Any takers?
Does this have something to do with gender fluidity?
I'm only joking, right? So tonight what I want to try and talk about is about encoding, data encoding for signal transfer, right? Now it's a bit of a fancy word, encoding. You see it come up in movies all the time where they say the signal's encrypted, we can't decode. No. When in reality, what it actually is a pretty simple and fairly universal item that we come across all the time, really. So I'm just going to start with a couple of examples. So why you would come across it, why you think about it. Let's take your internet at home has been upgraded. Virgin Media phone you up to say you've now got 50 megs per second rather than 20 megs throughput. Why has that happened? Have they torn up all the cables from the street and changed the cables? Maybe. Maybe they've improved the infrastructure somewhere, or maybe they've just improved the encoding scheme. They've improved the way they encode the signals that they send, so they can actually send more data to you and back and forth in the same amount of signal bandwidth. Right? Another one that you might notice on your computer, I have several different versions of the movie Interstellar on my computer. Some of them are 2.5 gigs in size, some of them are 1.5 gigs in size, one of them is 900 megs in size. And although I do notice some quality changes, the file sizes are enormous. Some of them are MPEG-4, one of them is AVI. They're in different encoded formats, meaning they take up different amounts of size on my hard disk. Not such a big deal these days, but it was a big deal when the iPod came out. And not the iPod even, the MP3 players. We called them MP3 players, in fact, because they played music in MP3. And what was MP3? MP3 was music encoded into a format called MP3 that was pretty crappy, let's be honest. If you play it on a nice music sound system, it sounds terrible. But it was fine when you were out walking around with your little earphones in, and it took up hardly any space. Look at a song in MP3, it's like 1.2 megs in size, tiny. Whereas if you are into music, and you have your music in FLAC, flawless lossless audio codec, it'll take up 10, 20 times that size. But when you play it on a nice sound system, it'll sound beautiful. So you're always playing these trade-offs, and this is one of the reasons why we encode. Encoding is key for downloading. I talked already about internet bandwidth, yeah? So you're downloading and pulling a movie from BBC iPlayer, I don't know, to watch it on your iPad when you're going to work, or you're illegally downloading something from somewhere and you're interested in the speed, whatever the case may be. Depending on the way it's encoded and transferred from them to you, will depend upon how quickly you can start watching the program. Right? So let's go back a bit. What do I mean by encode, and how do you do it? What is it to do encoding? So what I mean is taking information of any sort. It can be pictorial information, databases of files, sounds, and getting them from one point to another point across a different medium. Right? Now, if I take, for example, my thoughts, I think about something. I want to express it to David here. I want to say, David, I want to tell you this great idea I've had. I need to get that across to him, and I can't just beam my thoughts at the guy. I will need to encode that information into some sort of signal system that I can pass across. For me, that's usually English. That's usually English. Иногда это русский язык тоже. But it depends on something, doesn't it? It depends on a couple of factors to be able to do this. One, I have to have the ability to vary the state of the thing that I'm going to use as my communication medium. In speaking, that's been able to change, oh, whoa, whoa, hello. It's been able to change your voice, been able to change the way I move sound through my body to make sounds that David can recognize and know are words. Now, for example, David knows the sound system we're talking about when I use English. Yeah? Because the other element of the equation is a pre-agreed information system. David knows when I say the word bat. What do I mean by bat?
Not my wife.
Okay. So he knows I either mean a black bird thing that flies, not a bird, or some sort of thing, or a thing that you kill somebody with, yeah? He has an idea of what those things mean. But it depends on him knowing. Because, for example, you said you don't speak Russian, right? So I can talk to you in an encoded system like now, and you're understanding me. Но когда я говорю с тобой на русском языке, вы меня не понимаете, да? You don't understand it when I encode it across into a different sound system. It's not followed. So, let's take another one. because you can use a flashlight. A flashlight is a common way of demonstrating this concept. What's a flashlight for? It's for light. Yeah. You turn it on to light up a room and be able to see where things are, but you can also use it to encode information. If I'm on a mountaintop, I can go, I'm lost, I'm trying to signal to the little hill down the side, I can go beep, flash, flash, not flash, 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 not flash. The people down there, if they understand that Morse type system, they will know what I'm saying. And now he's saying, oh my God, we're starving, we're running out of food, it's really cold, I'm really tired, it's really, really cold. And they'll wonder why I'm such a moron that I'm writing that long, yeah? Because of course you can improve an encoding scheme. Why would I write beep beep, I'm cold, I-M-C-O-L-D, V-E-R-Y-C-O-L-D, C-O-L-D, C-O-L-D, when I could just write SOS, 3 letters, beep beep beep. Well, it takes slightly more beeps than that to send it, but you know what I mean. The idea is there that you can encode more narrowly. A famous encoding system, if my computer hasn't locked, is this one. Morse. The very, very basic, simple system. Yeah? Morse code. You beep, beep out each letter. Beep, beep, beep. So A is beep, non-beep. B is non-beep, beep, 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 etc., etc. Now you could write the word H-E-L-L-O, H-E-L-L-O, and somebody would know you're saying hello, right? That works. It's encoded information, isn't it? Or I can make it more efficient so I can type faster. I could pre-agree with David or with anybody that AGF means hello. Now I've got 3 letters instead of 5. I could pre-agree that AGS means bomb Moscow. Yeah? Or not bomb Moscow, it's a bad example, sorry. But that I can pick the sign system, and as long as they're pre-agreed, we're all cool. Technical stuff, obviously, the more higher up you go, encoding information for satellite transmission, it gets very complicated, modulating radio frequencies and all that stuff, but at the end of the day it's the same idea. You just take information in one state, you change the state of the thing that you're going to send. In the case of satellite communications, that's radio frequencies. We change the wave, the radio wave, into a way that we can interpret on the other end and know that that means a Netflix stream or whatever. Yeah. So why do we encode? I've already covered some of this. We encode for higher throughput. Typing, I'm very, very cold, I'm dying, takes too long, and when you're dying, it's quite hard to do. Just pre-beeping SOS is a lot faster. Yeah? It's higher throughput. We also do it for space, yeah? For how much space we have to save. And let me give you 2 examples. So Mamma Mia, the song Mamma Mia, Mamma Mia, Mamma Mia, let me go, right? Let's imagine that you said Mamma Mia is 1. It would just be 1, 1, 1, let me go. Yeah, much shorter. Much easier to do. Not as good a song, but the idea is easy. Well, let's take pictures, for example. Sending a video picture. If you were to send an entire video picture, every frame, boom, all the data of a frame, boom, all the data of a frame, boom, all the data of a frame, that's a lot of data. If, on the other hand, I agree a reference picture, let's take this picture, and then all I'll tell you is which bit changed. Just that bit changed. Just this little bit here changed. Just this little bit here changed. I can reduce the amount of information I have to send enormously down. And sending stuff across the world costs money, because I'm having to use people's equipment. So this is why we do it. So what does encoding? Anything. Your mouth. I'm encoding information right now. I'm encoding my thoughts onto words by modulating air, changing the waves of the air that's going out of my mouth so it comes to you. It could be done by my hands. If I knew how to do sign language, I could speak to you using my hands. It can be done using a device. Commonly, when it's done by a media device, we call it an encoder. And we call the other thing on the other end that picks it up and turns it back into something we can understand a decoder. As a little sidebar, when we used to have our home internet going on our phone lines, we didn't call it an encoder and a decoder. We called it a modulator and a demodulator, but it was doing the same thing. We called it a modem. You might remember the modems, yeah? So, encryption. I wanted us to touch on a point about encryption. Encryption is just encoding a signal, again, so it can't be understood. Right? It's pretty easy. It's pretty straightforward. You're just saying that instead of having beep, 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 in a way that somebody can, in a way that anybody could interpret, you'll change the signals. You'll change the letters and jumble them up so that nobody can understand them. Yeah? So we just muddle up the signals. So all this stuff, when you bring it back, when you're sitting at home watching a TV and you know, watching Netflix on the internet, talking to your mom on the phone. This stuff is all really basic. It's important technology and it's quite fundamental, but in the end of the day, it is just as easy as turning sounds into words. Not into it. Don't be frightened. Thank you.